If you ask me to write the electronic configuration of an element with electron number of what 90, believe me, I can't do that. But give me a second. With this approach, I can actually get any electronic configuration of any element at all, right? So now, do you know the reason why I can't do that? Because I actually cram those 1x, 2s, 2p, 3s, 3p, 4s, and 3d. For matter of fact, that is where I stop. For the other one, I don't know. But with this approach, you can get anyone. So that is the reason why I want to stay till the end of this video, because I'm going to show you a simple trick you can use to write early electric configuration of elements in the periodic table. Not only that, with the electric configuration, you can actually predict the group, the period, and the block of each of the elements in the periodic table. So make sure you stay to the end of this video. Let's get started. In order to write electric configuration, first of all, you must familiarize yourself with the 4 orbitals in chemistry, which are the x orbital, the p orbital, the d, and the f. Now, in the s orbital can convey of 2 electrons. P orbital can convey total of 6 electrons. D can convey 10 electrons. The F can convey 14 electrons. Right? Remember, X is having 1 suborbital, right? P is having 3 suborbital. D is having 5 suborbital. Then F is having 14, no 7 suborbital. 1, 2, 3, 4, 5. So you have to familiarize yourself this thing here. Whenever you see X orbital is 2 electrons. P orbital can convey 6 electrons. D orbital can convey 10 electrons. F can convey 14 electrons. Please, I will appreciate you if you are writing, because you really want to understand this stuff very well. So you have to take it down. So the next thing you want to know is that, now remember, we have a call K, L, M, N, O, P, Q, right? That means the first shell, the second shell, the third shell, the fourth shell, the fifth shell, the sixth shell, and the seventh shell, right? Remember, shell is also known as energy level, right? Shell is also known as the energy level. So here you have the first energy level, second energy level, third energy level, fourth energy level, fifth energy level, sixth energy level, seventh energy level. So you have to familiarize yourself with this thing here. So there are 2 main things you are going to work with. So if you really want to write electric configuration, like what I said, do with electron number of 90. Now there's a trick you can use in getting the electric configuration, which I'm going to show to you now. Remember, we have 7 energy level, right? So to do that, just watch me closely. What you have to do here, go to say 1x, 2x, 3x, 4x, 5x, 6x, 7x, right? After that, you leave this one here, come to this under 2 here, you now become 2p, 3p, 4p, 5p, 6p, 7p. After that, come to 3, 3d, 4d, 5d, 6d, 7d. Now after that, you come to this one here, 4f, 5f, 6f, or 7f. So this is what you want to do first, right? After this one here, you have to rule an arrow across this one like this. So you don't have to force it will enter. So here we have this one here. We have this guy. We have this guy. I have this guy. We have this guy. I have this guy. I have this guy. Right? So after this one here, you can see that the arrow is actually pointing up, right? So the first arrow is at 1 x. So here I have 1 x, right? The second arrow is at 2 x, 2x. The third one is having 2p, 3s, 2p, 3x, right? After that, here you have 3p, 4x, right? After that, now 3d, 4p, 5p, no 5 what x, 5x. Here we have what 4d, 5p, 5 what p, 6 what x. So that's how you do it till you get a what 7 what f. So this is the pattern we are using when writing electronic what configuration. You get that? So when you're writing electronic configuration, you don't need to cram it, or you don't need to what like write this one down. You just follow this pattern, then write like this. Then you can now what write any electronic what configuration. So I want to leave this one here. I want to write this out. So if you want to write electronic configuration of an element, now let's start with simple one, hydrogen. Right? Hydrogen, the electron number is what 1 because it's a neutral what atom, right? What about helium? Helium is what 2. Then here we have lithium is what 3. Here we have what? The helium is what 4, right? So now let's start with this one here. So now let's write the electronic configuration. The first one is what 1x. Then by doing that, x can accommodate what? X is what 2, p is what 6, d is what 10, f is what 14, right? So 1x, how many electrons do we have here? 1. So s can accommodate 2 electrons, but here we have 1. So here going to be what 1x1, right? That is it. Then helium is about 2 electrons, and s can accommodate only what 2 electrons. So going to be 1x what 2, right? Lithium is having 3, right? So it means that 1x will accommodate 2. Now, how many will be left is what? 1. So now move to the other one. 2x what? 1. You see how easy it is. Then, beryllium, which is 4, we have what? 1x2, 2x2. Right? Now, let's for what? Boron. Boron is what? 5. So here we are going to have what? 1x2. Here we have what? 2x2. How many electrons left? 1. So now move to 2p what? 2p what? 1. So after boron, here we have what? Carbon. Carbon is what? 6. So here we have what? 1x2, 2x2, 2p what? 2. So with this approach now, I believe you can for what? Nitrogen, oxygen, fluorine, neon. So go ahead and do it for me. Pause the video and do it for me. Let me give you a couple of seconds to do that. Right? I believe you have done that. Now let's see if you are correct. So nitrogen is what 7, right? Oxygen is what 8. Fluorine is what 9. Neon is what 10, right? So what happened here? Going to be 1x2, right? 2x2, 2p. Now how many left is what? 3. 3 is going to be here, right? Oxygen, here we have 1x2, 2x2, 2p what? 2p4. Then fluorine is what? 1x2, 2x2, 2p what? 5, right? So here we have neon, here we have 1x2, 2x2, 2p what? 6. You see how easy what it is, right? Now let's take another one here. Let's do for what? Sodium. Sodium is what? Is 11, right? So then I want to what? Fill 11 electron here. So here the first one is 1x2, right? 2x2, 2p what? 6. So out of 11 I'll use what? 10, right? That's what? 3x. So how many electrons? 1 electron left. So going to be 3x1. Magnesium is what? 1x2, 2x2, 2p6, 3x2, right? Aluminum is what? 13. Here we have 1x2, 2x2, 2p6, 3x2. How many left? 1. Now for what? 3p. 3p what? 1. Silicon is what? 15 or 14. Here we have what? 1x2, 2x2, 2p6, 3x2, 3p what? 2. Right? Next is what? Phosphorus. Phosphorus is what? Is 15, right? I believe you can do this one 16, 17, 18. So go ahead and do this one here. Try it.